Hope you are able to see my screen. So we are going to discuss about a tool called Kubernetes. Yesterday also I told you that it is a tool for Kubernetes is a tool for container orchestration. Very important point. If someone asks you what is Kubernetes, you have to answer that it is a container orchestration tool. It is a container orchestration tool. And in a short form, Kubernetes is called as K8S. Usually Kubernetes will be calling as K8S in a short form. Usually we will denote Kubernetes. Okay, sometimes whenever writing Kubernetes, whenever we want to specify Kubernetes, we will specify like K8S. Why we are writing K8S? There are 8 letters between K and S. You see the spelling of Kubernetes. In between K and S, there are 8 letters. That is why in a short form, we will write it as K8S. There are 8 letters between K and S. That is why we will in a short notation, we are calling it as K8S. And who developed this Kubernetes tool? Google, okay, then an organization, Google organization has created this tool called Kubernetes. And it is an open source tool. You know what is the meaning of open source? You don't need to pay anything for this. You can get freely. And there are subscriptions, there are licensed versions also. Okay, don't think that no licensed versions are there, no licensed softwares are there. You may get this, you may use the software for freely. But if you upgrade it, if you go for a licensed version, you may have some advantages. Okay, so if you want to know those differences, you can see. If you want to know those differences, you can able to understand. You can go to the Google and you can understand what is the difference between a community version and a licensed version. So that's fine. So what is the purpose of Kubernetes? Let's understand. Kubernetes, by using Kubernetes, we can create a cluster. We can create cluster, we can deploy, and we can manage clusters. Try to understand what is a cluster. Cluster is nothing but a group of computers. By using Kubernetes, we can create a cluster. What do you mean by cluster? Cluster is nothing but by using Kubernetes, we can create a cluster. What is cluster? Cluster is nothing but a group of machines. Cluster is nothing but a group of machines, computers, servers, whatever it is. Cluster is nothing but a group of servers. By using Kubernetes, we can create a group of servers. We can manage them. We can manage the clusters, and we can deploy our application into the cluster. Suppose in a cluster, how many servers can be there? That is up to our it is based on our requirement. Suppose if we need only 3 servers in a cluster, yes, we can create only 3 servers in a cluster. If we want to create 5 servers in a cluster, yes, we can create 5 servers in a cluster. But Kubernetes is used for creating clusters, managing clusters, and we can deploy our application into the clusters. Okay. So first we will try to understand. The features of Kubernetes. Very first advantage, I told you, Kubernetes is an orchestration tool. What is the orchestration? What do you mean by orchestration? Clustering any number of containers on different hardwares. Clustering any number of containers on different hardwares. This is called orchestration. So meaning, if you don't understand the meaning now, you will slowly understand. Don't worry about it, but try to understand the meaning here we are mentioning for orchestration. Clustering any number of containers on different hardwares. Otherwise, orchestration means, suppose I told you that the basic requirement for Kubernetes is Docker. If you know about the Docker, if you have studied about the Docker, it is very easy for you. To understand the concept of Kubernetes. And if you know very well about the container, you know what is container, right? Container is nothing but an application. You know what is Docker container? Container is nothing but an application. How we are creating a container? With the help of, how can we create container? Can anyone tell me how can we create a container, Docker container?
If we run the images,
yes,
it become container.
Very good. Yes. If we have the Docker image, we can run the Docker image, and then that image will become a container. That is how we are creating containers, right? So similarly, if we have the same image, we can deploy the same image. Into Kubernetes. we can deploy the same image. We can run the same image in Kubernetes also. And that will become an application. That will become a container. We can deploy the same images into Kubernetes also. So that's why it is called as an orchestration tool. But the only difference is in Docker, if you see, we are calling it as a container. The terminology is different. We are calling it as a container. Okay, we are calling it as a container. In Docker, the terminology we are using is container. But in Kubernetes, the terminology is pod, pod. Try to understand what is the difference between Docker and Kubernetes. In Docker, we'll be calling it as a container. If we run the image, that is called container. We are calling it as a container. But in Kubernetes, that is called as pod, pod. Okay. So orchestration means we can create any number of containers with the same image. If I have a single image, I can create any number of containers. We can create any number of containers and I can deploy any number of containers into the Kubernetes. Okay, that's understandable. If you understand the architecture of Kubernetes, you will understand slowly. The next one is auto scaling. Try to understand the concept of auto scaling. Why we are going for Kubernetes and all, I'll explain you. Let me take a paint for making you understand what is the purpose of this Kubernetes, why we are discussing this Kubernetes. You see here, you see the Docker concept. According to the concept of Docker, if I'm having a Docker image, okay, consider I have installed Docker and I'm having a Docker image. If I run this Docker image, that will become a container. We all know this. If I run this Docker image, okay, how I am running? By using a command called docker run, open to whatever it is, some image name I'm giving. That will become a container, right? That will become a container. Consider this is our container. So suppose if I create a single container, this single container needs to provide services for all the users. Consider there are many users for this application. There are many users accessing this application. What happens if multiple users try to access the same container? Why? Because we are having only single container, right? If multiple users try to access the single container at a time, so maybe the container gets down. Maybe the application gets crashed. Okay, we cannot say that. Why? Because load is not getting balanced anywhere. All multiple users are trying to access the same container. Okay, what do you mean by this container? Container is nothing but an application. I told you Flipkart container. If I am telling you it is a Flipkart container, it is nothing but Flipkart application. If I say Flipkart container is running, it is nothing but Flipkart application is running. So consider all the users. They are trying to access the application, Flipkart application at the same time. If there is only one container running, so if all the users are trying to access the same container, what happens? The load is not getting balanced, right? That is the issue. So for that purpose, what we are doing, we are taking the same image. Okay, we are taking the same image, the same Docker image I'm taking. Let's understand. I'm taking the same Docker image. Then I am going to deploy into multiple containers. This is one container. Okay, this is one container. But here in Kubernetes terminology, what I'm telling you, in Kubernetes, we are not calling it as a container. What we are calling it as? In Kubernetes, we are not calling it as a container. We are going to call it as
pod.
In Kubernetes, we are calling it as pod. This is called pod. Okay, this is called pod. So by using a single image, I can create any number of pods. By using single Docker image, I can create any number of pods. So that what happens? So here we are creating multiple pods. This particular pod can provide services to multiple users. This particular pod, whatever the pod we have created here, this pod can create services to multiple users. Okay. Sorry. And pod 1, consider this is pod 1, pod 2, and pod 3. Pod 1 can provide some pod 1 can provide services to some users. Pod 2 can provide services to some other users. Pod 3 can provide services to some other users. So what is happening here? Load is getting distributed. Load is getting distributed. So we have the concept of creating pods in Kubernetes. You can create a pod, and each and every pod can provide services to the users. We can create any number of pods in a single server. In a single server, we can create any number of pods. Where we are creating these pods? In a single server. Where we are creating this container? In a server only. Okay, we can create even multiple containers also. But Kubernetes is a tool that is more beneficial, that has more advantages for deployment. So in Kubernetes, what we are doing in Kubernetes, we are installing Kubernetes in some server. We are installing Kubernetes in some server. So what Kubernetes can do, with the help of Kubernetes, we can create a cluster. What do you mean by cluster? Can anyone tell me? What do you mean by cluster?
Group of containers.
Yes, group, not group of containers. Cluster is nothing but group of machines actually.
Machines.
Okay, the actual meaning of cluster is, in K8S, we can create a cluster. Okay, meaning of cluster is nothing but a group of machines or group of computers. Cluster is nothing but a group of computers. మనం instances అంటాం ఇక్కడ యాక్చువల్గా అయితే ఓకేనా, group of instances, group of machines, group of servers, whatever it is. So in each and every machine, okay, cluster is nothing but group of machines. In a single machine, we can create any number of pods. In a single machine, we can create any number of pods. Okay, so suppose if in a single machine, if you are creating 3 pods, okay, in a single machine, if you are creating 3 pods, and if we have 3 machines, how many pods we can create it?
9 pods.
9 pods. Consider we are creating 3 pods in a single machine. If we are creating 3 pods in single machine, and if we have a group of 3 machines, what we can do? We can create totally 9 pods, and all the 9 pods they are going to provide services to the user, so that the load is getting distributed. Traffic will not be more. Load is balanced. Local load is getting balanced. So for that purpose, we are using Kubernetes. The main advantage is auto scaling and load balancing. See, load is getting balanced. Here we are creating multiple pods, and these pods are providing services for multiple users, for group of users. And here we are balancing the load. Similarly, auto scaling feature is also there. Auto scaling. See, whenever dynamically, if number of users increased, suddenly if the number of users accessing the Flipkart application has increased suddenly, what happens? This Kubernetes is having one more advantage, like auto scaling. It can increase the number of pods. Consider we are creating only 3 pods. The minimum number of pods we are creating is 3, and we can set that maximum to 5 or 7, whatever it is. We can give some maximum number. So what happens whenever a traffic increases, based on the users, the number of pods will also get increases inside each and every machine. Inside each and every machine, the number of pods will also get increases. Okay, why the number of pods are getting increases? Because the number of users are increasing. To provide services to all the users, here all the pods are busy. Whatever the existing pods we have, all the existing pods are busy. So we have a feature called auto scaling. By the name itself, it is indicating auto scaling. Auto means automatically it will scale up the pods. Otherwise, if there is no demand, if there are only less number of users, it will also go for scaling down. Scale up, scale down. We have already discussed this feature in the AWS. Do you remember? Auto scaling, increasing.
Yes,
auto scaling means increasing, automatically increases. Okay, so like that, we have that feature in the Kubernetes. That's why we are going with the Kubernetes. There are many advantages with the Kubernetes. You will understand slowly. So let me open So orchestration, we can create a group of machines, and we can create any number of containers on different hardwares. Auto scaling means whenever a capacity increases, whenever the number of users increases, automatically the number of pods can be increased, or the number of pods can be decreased. So what happens? Auto healing. This is a wonderful feature of Kubernetes. Auto healing. Suppose if any container is crashed, will get crashed because of some reasons. Okay, I'll mention you. Okay, we will discuss later what are all the reasons why the container will get crashes. I told you already one reason. If multiple users, okay, if more number of users try to access the same pod, maybe because of that reason also the container may get crashes. So crashed container means what? Crashed container. Suppose if any container is crashed, new containers will be created in place of crashed containers within seconds. If any container will get crashed, new container will be created in place of the crashed containers. This is nothing but handling the failover scenarios. Okay, this is a feature called handling failover scenarios in the Docker Swarm. Docker Swarm is also related to Kubernetes only. It is related. It is also related to Kubernetes tool only. Once you understand Kubernetes, Docker Swarm is also a same tool. Docker Swarm and Kubernetes both are same. Okay, both are for the same purpose. Same in the sense both are for the same purpose. So auto healing feature you understood. New containers will be created in place of crashed containers. Load balancing I already told you. Rollback. What do you mean by rollback? Suppose I'm having a Docker image. Okay, consider I'm having a Docker image. So consider I'm having a Docker image with the name called Flipkart 1.1. I'm having an image called Flipkart 1.1. Consider I'm going to deploy this image into the Kubernetes. Then all the pods will be created. Pods will be running with this version. Okay, if pod is running, it is nothing but what? I told you already, in Docker, we are calling it as a container. In Kubernetes, we are calling it as a pod. If pods are running, it is nothing but application is running. If I say two pods are running, how many applications are running?
Two applications are running.
Two copies, not
two copies of that application.
Two copies of same application. Flipkart 1.1.1 application is running, and how many copies are running? If I say two pods are running, two copies are running. If I say three pods are running, it is nothing but three copies are running. Why we are having multiple pods? Why we are creating multiple pods and all? What is the necessity? For the purpose of
Balancing the load.
Load balancing. If I am having only single pod, what happens? If multiple users try to access the same pod at a time, it may get crash. That's why to balance the load, I'm creating multiple pods. And each and every pod will be providing services to the users. So last one is rollback. Try to understand rollback. Consider we are using a Docker image called Flipkart 1.1.1, and we have deployed into the Kubernetes. Consider two pods are running with the same image. We can create any number of pods with the same image. By using same Docker image, we can create any number of pods. Consider two pods are running. Okay, and anyhow, it doesn't matter how many pods are running or not. Okay, suppose if I'm using this particular version, and consider there is a drawback with this version. I have recently deployed this particular version. Recently, I have used this Docker image for creating pods, but there is a drawback with this image, and it is giving some issues. There are some issues with the particular image. Then what can I do? I can go for the previous version. Consider if the previous version is 1.1.0, what I can do is, instead of this image, I can deploy this particular image so that application will be running without any disturbances. And before you solve the issues with this Docker image, okay, if there are any issues with the Docker image, current Docker image, you can roll back to the previous version. That option is there. Rollback option is there. If you face any issues with the current version, you can roll back the previous version until you resolve the issues of current one. So these are the advantages we are having with the Kubernetes. Let's try to understand the Kubernetes architecture. Kubernetes architecture. I told you first one, cluster. We can create cluster. With the help of Kubernetes, what can we do? With the help of Kubernetes, we can create a cluster. Okay, we can create a cluster. So what do you mean by cluster here? Cluster is nothing but here, according to our Kubernetes architecture, cluster is nothing but it is a combination of one master and multiple nodes. Okay, one master and multiple nodes. Kubernetes cluster is a combination of one master and multiple nodes. Suppose if I create a cluster of 3, okay, if I create a cluster, when I'm creating a cluster, it will ask you how many nodes you want to create. If you pass the value as 3, that means what? How many number of nodes will be created? If I give the cluster size as 3, how many nodes will be created?
One master and 2 nodes?
No, that is wrong.
3 nodes.
Actually, 3 nodes will be created. Okay, if you give the cluster size as 3 nodes will be created. And in the cloud like Amazon, in clouds like Amazon, Azure, or Google Cloud, whatever it is, you don't need to worry about the master. Okay, you don't need to worry about the master. Master is being provided as a service. You don't need to create master. You don't need to create master. You don't need to worry about the master. See here. Okay. So cluster is a combination of one master and multiple nodes. As of now, you try to understand cluster is a combination of multiple nodes. Anyhow, master will be there. Master is being provided as a service by the AWS cloud, or otherwise whatever the cloud you are using. You leave about the master. You don't need to worry about the master. Why? Because cloud itself is taking care of the master component. And if you give the cluster size as 3 nodes will be created. If you provide the cluster size as 2, only 2 nodes will be created. Okay, if you give the cluster size as 5 nodes will be created. What do you mean by node? What do you mean by node? Node is nothing but
pod.
Machine. Node is nothing but machine. Node is nothing but machine. Okay, computer. Okay, multiple nodes means here we are going to create computers, multiple servers. Node is nothing but a computer. Okay, so if you give the cluster size of 3, how many computers will be created in a cluster? 3 computers will be created in a cluster. Okay, then pod is the basic unit. Pod is the atomic unit of deployment in the Kubernetes. What is the important thing, most important thing in Kubernetes? Pod. We will call it as pod. So pod is what? What is actually the meaning of pod? Pod is nothing but container. Usually I told you that in Docker we are calling it as a container, but in Kubernetes pod is nothing but a container. But inside pod we can have one or more Docker containers. Pod is the basic unit of deployment in the Kubernetes. No confusions. Whenever I use the term called pod, you please try to understand pod is nothing but a Docker container. మనం డాకర్ లో ఏదైతే కంటైనర్ అని పిలుస్తామో క్యూబర్నెటిస్ లో ఏమని పిలుస్తాం దాన్ని పాడ్ అంటాం అనుకోండి. ఓకే, సో node is controlled. What do you mean by node? Just now I told you node is nothing but computer. So all the nodes are controlled by Kubernetes master. So whenever you see this point, you leave about all the points I'm giving you. Cluster is a combination of one master and multiple nodes. Leave about the master. If I give the cluster size as 3, it will create only 3 nodes. And whenever I'm using Kubernetes, the most important term I use is what? Pod. Pod is nothing but what? It is similar to our pod is nothing but it is similar to our Docker container. Where the pod will run? Inside the node. Pod runs on node. Where this pod will run? Pod will run on computer. Pod will runs on computer. And node is controlled by whom? The pods are running in nodes, and the nodes are being controlled by Kubernetes master. Nodes are being controlled by Kubernetes master. Okay, I'll show you the architecture. See the diagram. Can you able to see this one? This is the Kubernetes architecture, and this is the diagram of only. This is the diagram. This diagram shows you Okay, complete understanding of Kubernetes architecture. Here we have two parts, right? The first part and second part. The first part shows you Kubernetes master. Okay, the first part gives you the understanding of Kubernetes master. Okay, top one, top refers Kubernetes master. Bottom one refers nodes or minions. What do you mean by node? Node is nothing but a computer. Node is nothing but a computer. And you can see what are all the components we have in the Kubernetes master. These are all the components we have in the Kubernetes master. Kubernetes master is also a computer. Don't think that Kubernetes master is something else. Kubernetes master is also a computer. It is also a computer, and nodes is also a computer. But in the cloud, we don't need to worry about the master. Why? Because master is being provided as a service in the cloud. We don't need select. We don't need to take a dedicated machine for master. That's why I told you, right? Whenever you are creating a cluster in the AWS, whenever you are creating a cluster, you need to provide the cluster size. If you provide the cluster size as 3, how many nodes will be created? 3 nodes will be created, and the master is being taken care of cloud. Okay, master is provided as service by the cloud. Okay, master కూడా ఒక machine create చేసుకుంటుంది, కానీ మీరు చెప్పాల్సిన అవసరం లేదు. మీరు క్లస్టర్ సైజ్ 3 ఇస్తే మీకు నోట్స్ 3 ఇస్తుంది అనమాట. మాస్టర్ని ఎవరు మేనేజ్ చేస్తారు? క్లౌడ్ మేనేజ్ చేస్తుంది. ఓకేనా, ఏడబ్ల్యూఎస్ అయితే ఏడబ్ల్యూఎస్, గూగుల్ క్లౌడ్ అయితే గూగుల్, ఏదో ఏ క్లౌడ్ అయితే ఆ క్లౌడ్ మేనేజ్ చేసుకుంటుంది. ఇట్ ఈస్ బీయింగ్ ప్రొవైడెడ్ as a సర్వీస్. మాస్టర్ని ఒక సర్వీస్ లా చేశారు అనమాట. ఓకేనా, దీంట్లో చూడండి Kubernetes master. When you go to the Kubernetes master, in Kubernetes master we have few components, like first one Kube API server. Okay, try to understand. The first one is Kube API server, Kube scheduler, controller manager, etcd. We have components like Kube API server, Kube scheduler, controller manager, etcd. Okay, these are the components we have in the Kubernetes master. When you come to the node, in each and every node, okay, I'm talking about one node only, single node. This diagram represents only single node. Okay, you can assume if your cluster size is 3, how many nodes will be there like this? Similar to this, you can assume some other nodes. This is a single node I am talking about, single node or minion. Either we can call it as a node or minion. You can call it as a node or minion. Okay, so in a single node we can have these components, like you see we have a component called kubelet, kube proxy. We have a component called kubelet, kube proxy, and we have a component called container engine. Kubelet, kube proxy, container engine. Okay, so we have a master machine and we have a node machine. These are the components we have in the master machine. We will try to understand about each and every component in the master machine. We will try to understand about each and every component in the master machine, and we will also talk about each and every component in the node as well. First one, in the master we have a component called Kube API server. Okay, we have a component called Kube API server. Let me open this. What I told you, master contains 4 components. What are the 4 components that are being provided by the master? Kube API server, Kube scheduler, controller manager, and etcd. Okay, so what is Kube API server? See, as a DevOps engineer, you should be able to write an YAML file. You should be able to create an YAML file. Okay, as a DevOps engineer, you should be able to create a YAML file. What is this YAML file? I already told you. What is YAML file? YAML is not a scripting language. What is YAML? YAML is a file format. I already told you. While we were discussing about Docker, there we have written some Docker compose file, right? Docker compose. While writing Docker compose, I have shown you Docker compose. We will write input in the form of YAML file, and I told you that YAML is not a YAML is not a scripting language. YAML is a file format. YAML is a file format. Left hand side keys, we need to provide keys. Right hand side value should be given. Left hand side keys, right hand side values. Left hand side keys, right hand side values. As a DevOps engineer, you should be able to create an AML file. What is this AML file contains? What this AML file contains? First one, number of nodes you want. So whatever the input you want to give, you have to provide the input in the form of AML. So what is the input we are going to give? What input actually we are going to give in the AML? Number of nodes you want, and you need to mention how many pods you are going to create in each and every node. So suppose if you want to create a cluster, how many nodes you want to create? And in each node, you should have how many pods? How many pods you want to create in each and every node? And you should also mention how many containers you want to create in each and every pod. See, so far, as per our understanding, pod is nothing but a Docker container. But in Kubernetes pod, we can have multiple Docker containers. We can create multiple Docker containers in Kubernetes pod. Pod is the smallest thing in Kubernetes. Whenever I am using Kubernetes, I refer the term called pod. But inside the pod, how many containers we can create? We can create any number of containers. That is also up to our wish. Okay, we will see. But as of now, no, don't confuse. What we are going to do is, as a DevOps engineer, you should be able to write an AML file, and that AML file should contain how many pods you want to create and how many containers you want to create inside the pod. Leave about all these things. If you see the AML file, you will understand everything. So all the information will be available in the AML file. We are going to provide the entire information in the AML file, and the AML file is also called as what? AML file is also called as what? Manifest file. And this AML file should be provided to the Kubernetes master. Whenever we are writing our information, we are writing all our input. We are writing all our input in the AML file. We are submitting that input to the. We are providing that input to the. We are giving that input to the Kubernetes master. Okay, in Kubernetes master, you have seen that what are the components we are having in Kubernetes master. In Kubernetes master, you might have seen these are the components we are having, right? In Kubernetes master, you see what is the first component we are having? Kube API server. We are giving our AML file. You see, we are writing AML file as a DevOps engineer. We are writing our AML file, and we are giving that AML file to whom? Which component? We are giving our AML file to the component called Kube API server. You see the diagram. We are writing an AML file and we are giving input to the Kube API server in the master. This Kube API server is a component which is present in the Kubernetes master. We are giving the AML file as an input to the Kube API server. What is the responsibility of Kube API server? Kube API server will act as a receptionist. Kube API server will act as a receptionist. You see here, Kube API server acts like a receptionist. It receives the AML file and it passes the request to the kube scheduler. The task of Kube API server is just to take the AML file. It will receive the AML file and it will pass the request to the kube scheduler. That's it. It will take the AML file and it pass the request to the kube scheduler. That's it. Look at the diagram. It is taking the AML file and it is passing the AML file to the kube scheduler. It is receiving the AML file and passing the AML file to the kube scheduler. And the very important component is kube scheduler. What this kube scheduler will do? Kube scheduler will take the action. Kube scheduler in the master component is responsible for creating pods as well as containers. So whatever the AML file you write, that AML file will be understandable by the kube scheduler component. Based on the AML file you have written, based on the input you have provided, that kube scheduler will create pods as well as other things. So kube scheduler is responsible for taking the action based on the AML. We will write the AML file, try to understand. We will write the AML file and we are giving AML file to whom? We are giving our AML file to a component called Kube API server in the master. Kube API server will act like a receptionist. It will receive the AML file and pass the request to the kube scheduler. Now kube scheduler is the component which will take the action. Kube scheduler will create pods and containers. Kube scheduler will create pods and containers. Then there is one more component called etcd in the master. In master machine, we are having one more component called etcd. What is this etcd? Etcd is also called as cluster store. etcd is also called as a cluster store. So what do you mean by cluster store? It has the information of the complete cluster. It will have the information of about the complete cluster. That means it will store the information like how many nodes are there, how many containers are there, everything. It will store the information in the form of key value pairs. So it is like a database. etcd is like a database regarding your cluster. It will maintain the entire information about your cluster, how many nodes are there, how many pods are created, okay, how many containers are running each and every pod. Every information will be maintained by etcd. If someone asks you what is etcd is like a cluster store, otherwise it is like a database to store the information about the cluster. It will store the information about the cluster. Okay. So you understood, try to look at the diagram. We are talking about the components in the master. We have a Kube server. We will write YAML file. As a DevOps engineer, we will write YAML file. We will provide the YAML file to the Kube server. Kube server will just forward the YAML file to the Kube scheduler. Kube scheduler, what is the task of Kube scheduler? It is the main important component. Kube scheduler is the important component that will take up the action based on your YAML file. మనం ఏదైతే YAML లో రాసామో దాన్ని బేస్ చేసుకొని ఇది యాక్షన్ పర్ఫామ్ చేస్తాం అన్నమాట. It will create pods based on the YAML file. So what is the use of etcd? Etcd is like a cluster store. It will maintain the entire information about the cluster. What about this one, controller manager? So controller manager, the task of controller manager is it will always make sure the actual state is equal to desired state. Suppose if in the YAML file, if you write the number of pods you want to create is 2. In the YAML file, we have written like the number of pods we are going to create is 2. Okay. Then what is happening? Suppose if if container crashes, what I told you, because of some reason, if some pod get crashed, how many containers will be left? In the YAML file, we have given input to create 2 pods, and 1 pod got crashed because of some reasons. Now, how many pods should be there?
2 pod only.
1 pod, right? Okay, we have given 2 pods. We asked it to create 2 pods, and 1 pod got crashed. Only 1 pod is left. But controller manager, what is the task of controller manager? Controller manager will look whether the actual state is equal to desired state. మనం YAML లో ఏమి ఇచ్చాం? 2 pods అని ఇచ్చాం. అది యాక్చువల్ స్టేట్. కానీ డిజైర్ స్టేట్ ఏముంది? ఒకటే ఉంది. కాబట్టి ఏంటంటే రెండో పాడ్ కూడా క్రియేట్ చేస్తుంది వెంటనే. ఇట్ విల్ క్రియేట్ ద సెకండ్ పాడ్ ఫ్రెష్లీ. అందుకని మనం వాళ్ళు చెప్పే ఆటో హీలింగ్. We already discussed about the feature called auto healing. If any pod is crashed, automatically a new pod will be created. మనం ఏం చేస్తాం అవసరం లేదు, Kubernetes ఫీచర్ అది. ఏదైనా ప్రాబ్లం వచ్చి ఒక పాడ్ క్రాష్ అయిపోతే ఆటోమేటిక్ గా ఇంకొక పాడ్ క్రియేట్ అయిపోతుంది. So that is the task of controller manager. Controller manager will looks after whether the actual state is equal to desired state. What do you mean by actual state? Whatever the contents you have written in the YAML file, that is the actual state. And present one, యాక్చువల్ స్టేట్ మీరు 2 పాడ్స్ క్రియేట్ చేయమని ఇచ్చారు. డిజైర్డ్ స్టేట్ లో ఒకటే ఉంది. కంట్రోలర్ మేనేజర్ ఏం చేస్తుంది? ఇట్ విల్ బ్రింగ్ ద యాక్చువల్ స్టేట్ ఇంటూ యాక్చువల్ స్టేట్ ఈజ్ ఓన్లీ 1 పాడ్ ఇస్ దేర్. యాక్చువల్ స్టేట్ అంటే ఒక పాడ్ మాత్రమే ఉండేదాన్ని యాక్చువల్ స్టేట్ అంటాం. డిజైర్డ్ స్టేట్ అంటే మీరు YAML ఫైల్ లో 2 పాడ్స్ కావాలని ఇచ్చారు. వాట్ ఈస్ అవర్ డిజైర్డ్ స్టేట్? ఇన్ ద YAML ఫైల్ we have mentioned we require 2 pods. So it will bring that actual state into desired state. Controller manager, the task of controller manager is always it will bring the actual state into desired state. It will bring up the actual state into desired state. Okay, you understood, right? So these are the components we are having in master. These are the 4 components. Very, very important thing. Definitely, if you attend an interview on DevOps, definitely they'll ask you to explain about Kubernetes architecture. So Kubernetes architecture, how you have to start with. If someone asks you to start explaining about Kubernetes architecture, so Kubernetes architecture is a combination of, it is a cluster actually. Cluster is a combination of master and multiple nodes. So whatever the cluster size we provide, based on the cluster size, the nodes will be created. In the cloud platforms, we don't need to take care of master component. Master is being provided as a service. And what are the components we are having in the master? There are 4 components in the master. What are they? Kube API server, Kube scheduler, controller manager, as well as etcd. What is the task of Kube API server? It will act like a receptionist. Okay, receptionist. Why we are calling it as a receptionist? If you go to some hotel or some place, so receptionist will be there. First he or she will take care of us. Okay, based on our requirements. So that is why whenever we are writing an YAML file, we are giving that YAML file to the Cube API server, and that Cube API server will forward the YAML file to the Cube scheduler. Cube scheduler will create pods based on the YAML file we are writing. And what is etcd? Etcd will maintain the cluster, store information about the cluster, and controller manager will always looks for actual state is always equal to desired state. You understood the meaning of actual state equal to desired state, right? You understood the meaning of actual state is equal to
Yes, sir.
desired state. Okay. So in the YAML file, if we write two pods, if we give the input as two pods, so because of some reasons, if any pod gets crashed, that actual state will be now only one pod. Okay. So controller manager will not leave that. Controller manager will bring that actual state into desired state. Each and everything is a program. Cube API server is a program. Cube scheduler is a program. Controller manager is a program. etcd is a program. Each and everything is a program here. Okay, we are calling it as a components. Each and everything is a program. That's fine. Now you go to the node. Okay, what are the components we are having in the node? There are three components in the node. One is kubelet, kubeproxy, container engine. We have a component called kubelet. First component is called kubelet. Second component is kubeproxy. Third one is container engine. Kubelet, kubeproxy, container engine. Kubelet, kubeproxy, container engine. What do you mean by kubelet? Let's understand what is kubelet and all. Okay, so let's see what is kubelet and all. We're talking about a node. Node contains three components. First one is kubelet. Kubelet is also called as an agent. It listens to the Kubernetes master. So kube scheduler component will communicate to the kubelet. Let's go to the diagram. We have a component called kube scheduler in the master, and that kube scheduler component will communicate with the kubelet component in the node. So anyhow, we already understood that kube scheduler task. Kube scheduler will perform the action. Kube scheduler will perform the action based on the YAML file. So while performing the action, kube scheduler component will communicate with the kubelet component in the node. Kubelet component in the node. How we will get these programs? Kubelet, kube master. In master, how we are getting these programs, and in node, how we are getting these programs. So whenever we are going with a software, whenever we are going with a tool called Kubernetes. So Kubernetes, whenever we are installing Kubernetes, all these programs we will get. Okay, in master we will get these programs. In node machines we will get these programs. Whenever we are creating a cluster is nothing but a group of machines. In all the group of machines we will get these programs. In all the group of machines we will get these three programs. In master machine we will get these programs. So kube scheduler will communicate with the kubelet component. Kube scheduler will communicate with the kubelet component. Okay. So for regarding what it will communicate, it will communicate with the kubelet kube scheduler will communicate with the kube scheduler. Sorry, this one. Kubelet is also called as an agent. Try to understand. Kubelet is also called as an agent. It listens to the Kubernetes master. In Kubernetes master, it listens to the kube scheduler component. So kube scheduler component will communicate with the kubelet, and then kubelets will communicate with the container engine. It will create the containers. Try to understand. So kube scheduler is communicating with the kubelet, and kubelet is creating these containers. Kubelet is an agent. It is listening to the master. In which component? It is listening to the master. In master, it is component to which it is communicating to which component? Kube scheduler. Okay, it is listening to kubelet is listening to the kube scheduler. Okay, so this kubelet will create containers, the required containers. That is nothing but pods. Okay, kubelet will create the pods. This kubelet will create the pods. And there is one more component called kubeproxy. The main task of kubeproxy is it will assign IP address to each and every pod. Kubelet will create pods. Kubelet is an agent that listens to the kube scheduler component in the master, and it will create pods. Okay. And what is the meaning of kubeproxy? Kubeproxy is a component. It will assign IP address to each and every pod. Suppose if kubelet creates 3 pods, for each and every pod, it will assign an individual IP address. For each and every pod, it will assign some IP address. I already told you what is IP address. In EC2 machines also, I have shown you where the IP address will be. Like that, whenever a pod is created, each and every pod will have some will be having some IP address. So kubeproxy is a component. It is a program in the node machine. It will assign some IP address to the pod. Usually, it will assign some IP address to the pod. That's how it actually happens. So hope you all understood the components in the master as well as node. Okay. So you see here in master, I told you we will write an YAML file. We will give the YAML file to the Cube API server. Cube API server will communicate with the Cube scheduler. Cube scheduler will perform the action. How it is performing the action? Can you see how it is performing the action? It is communicating with the kubelet agent in the node. Okay. So controller manager, task of controller manager, actual state equal to desired state. It will always look after the actual state is equal to desired state. etc is like a cluster store. It will maintain the information about the entire cluster. And then if you go to node machine, in node machine we have three components. We understood about kubelet. Kubelet will listens to the master. Kubelet will listens to the master. It will create the pods. And kubeproxy is a component which assigns IP address to the pod. Suppose if kubelet creates two pods, kubeproxy will assign IP address to each and every pod. Kubeproxy will assign IP address to each and every pod. This is about the Kubernetes architecture. If you have any questions on the Kubernetes architecture, please let me know. We will discuss about it.
Sir, can you explain one more time about etcd?
etcd, it is like a database. So etcd stores the information about the entire cluster. So what is the cluster size? And cluster size means how many number of nodes are there. Suppose if 3 nodes are there, in each and every node, how many pods are there? Suppose if a pod is there, inside pod we can create number of containers. That is also the concept of Kubernetes. Inside each and every pod, we can create any number of Docker containers. The smallest unit we are talking here is pod in Kubernetes. But inside the pod, we can have multiple containers. So that information will be maintained by the etcd. That is why etcd is called as a cluster store, or otherwise it is a database which stores the information about the entire cluster. Okay, what is the class? How many nodes are there? How many pods are there inside each and every node? చూడండి మనం ఏం చేస్తున్నాం, నోడ్స్ ఫస్ట్ క్లస్టర్ అంటే నోడ్స్ ఎన్ని నోడ్స్ వస్తాయని చూస్తాం. వన్స్ నోడ్ క్రియేట్ అయిన తర్వాత ఒక నోడ్ లో మళ్ళీ ఎన్ని పాడ్స్, ఒక్కొక్క నోడ్ లో మళ్ళీ ఎన్ని పాడ్స్ మనం క్రియేట్ చేయొచ్చు అనేది మనం చూస్తాం. We can create any number of pods inside each and every node. Once a pod is created, what we can create inside pod? What we can create inside pod?
Number of containers.
Understood, right? So try to understand. If suppose take see, consider this is a cluster, and inside the cluster I am going to create 3 machines. This node 1, node 2, node 3. 3 nodes are there. Cluster is created. Inside cluster 3 nodes are created. Inside each and every node, we can create a pod. This is pod. And you see, inside each and every pod, how many pods we can create? It is not, I am not saying that only one pod can be created. Okay, any number of pods can be created. You see, I'm just creating 2 pods in each and every node. 2 pods in each and every node. Once a pod is created, again, what we can do? We can create, once a pod is created, we can create any number of containers inside, any number of Docker containers inside it. Okay, if you want to create only 1 container, you can create. Otherwise, 2 Docker containers we can create. This is the actual architecture of Kubernetes. That's it for today. We'll meet tomorrow. If you have any doubts still, please let me know. We'll see the practicals of Kubernetes tomorrow. Thank you all. Meet you tomorrow.